Dear Chair, dear ladies and gentlemen, welcome to my presentation about our paper Parametric Structural Optimization Tool for Flexible Industrial Buildings, Evaluation through an Experimental Study. My name is Julia Reisinger and I'm a PhD student at TU Wien at the Department of Integrated Planning and Industrial Building, and my supervisor is Kovacic. So what is the research motivation? We aim to plan flexible industrial buildings, but it's a very interdisciplinary task containing models from architects, from production planning, from structural design, building service equipment, including a lot of information and different models. But currently, design process is still sequential. We have a lack of integration and interoperability of processes and models, and there are lack in decision support systems, like in multidisciplinary decision support systems. Furthermore, manufacturing systems are, because of technology, because of increased production in batch size of 1, we have reconfigurable manufacturing systems. They are changing a lot, but we have rigid structural building systems which often cannot accommodate these changes, which leads to early rescheduling or demolition. So our research motivation is the coupling of building and manufacturing processes and models with the simultaneous optimization of building structures towards maximum flexibility, and to develop a decision support for early design stages. The research is conducted within the research project BIM-Flexi, funded by the Austrian research agency FFG. And the research aim of BIM-Flexi is to develop a digital platform to increase the flexibility of industrial buildings towards rapidly changing manufacturing systems, to improve the economic and environmental building performance in long term. Here you see the workflow, a very basic workflow of the digital platform aim. And in the middle, there is the parametric structural multi-objective optimization and decision support tool, which I will call POD, for flexible industrial building design. And in this paper, we evaluate this tool. So the hypothesis we are following or stating in this paper is that a parametric multi-objective optimization and decision support tool for automated structural and layout optimization industrial building design, which integrates production planning, improves the interdisciplinary cooperation, the design process, and the design results to generate flexible industrial buildings in 2 ways. By integrating stakeholder in a digital interdisciplinary platform, supporting collaborative decision-making at early design stage, and by a tool itself, which automatically analyzes and optimizes the building load pairing structure according to the production layout, providing real-time feedback on the structural performance and fast impact exploration of different design decisions. Here you see the framework of the developed POD tool. At first, you have the production layout input, and the production layout optimization integrated into the building design. And then optimization takes place, and we have decision support at the end with performance evaluation. And then we have an automated link to automated BIM and FEM, finite element export. So the experimental study, what is the goal and the scope? The study aim is to evaluate the benefits and improve the POD tool, to identify the potentials for the optimization of process integration of the POD tool. And the research questions we are following is, can a parametric structural analysis and optimization tool designed for early industrial building design support interdisciplinary teams in efficient collaboration and provide effective decision-making support? And who is the primary beneficiary of the tool, the civil engineers or the architects, or is the benefit equal? So the test environment is our yearly interdisciplinary design course offered at TU Wien, the Integrated BIM Design Lab, which was conducted last winter semester with 8 student teams consisting of always 2 architects and 1 civil engineer. And we gave them, after working with the POD tool and conducting their design task of an industrial building project from packaging industry, gave them questionnaires and interviews with quantitative and qualitative evaluation. So how does the experiment design looks like? So we gave them this design task of a production building from packaging industry with 1,700 square meters located in Innsbruck, Austria. The decision variables they could choose and should find the optimal setting were the structural system type, the construction material, the axis grid of the columns, and the clear room height. And the objectives they had to optimize, they had to follow were the minimum net cost of the construction, to maximize the free room height, because that increases flexibility, and the minimum column amount that also increases the flexibility of a free production layout. So at first they had to sit together, do the functional design proposal, and also define discipline-specific goals, arrange in a team, go through the building program, production program. And then they used the POD tool, which is modeled in Rhino 3D and Grasshopper, and conducted a variant study and conducted the decision making. They chose a final solution after the variant study. And then exported it into the BIM model in Archicad or into the finite element model in Global RFM for do post-processing and BIM processing. What were the quantitative results? So we conducted a survey evaluating the satisfaction working with the tool, which consisted 4 questions about the process evaluation, like the tool helped me to perform my tasks efficiently. With the outcome evaluation, the tool aims that the goals I have set have been achieved. The collaboration, the tool supported effective team communication and collaboration. So in total, 12 questions on satisfaction working with the tool. And we asked them questions about the tool specific tasks, and evaluated it with a technology acceptance model. So we asked them about the ease of use. For example, the tool increases my productivity. We asked them about the usefulness of the tool. In total, I think the tool is useful for decision support tasks and the interoperability of the tool. Overall, I think the tool is compatible with other systems. And they rated it within a 5 Likert scala, with 5 is high, agree, and 1 is low or disagree. These were the results of the quantitative evaluation. So when we look at the first graphic, satisfaction working with the POD tool is slightly better rated by the architects than the civil engineers. The civil engineers were not really happy about the collaboration, that was because afterwards in the qualitative evaluation, we recognized that civil engineers were more the ones who had to work with the tool. So the architects decided the structural engineer has to use the tool and work with the tool. And so they missed some architectural input or working together. And the satisfaction with technology of the POD tool is also better rated by the architects, but we see, especially here in the quantitative evaluation, with including all disciplines, that the ease of use and the interoperability of the tool can be increased and are not rated that good. So furthermore, we asked them what were their experience before working with parametric software and modeling and with optimization and decision support tasks. So the architects, what we found is have already higher experience with parametric software and modeling and better experience with optimization and decision support tasks. Where in fact the civil engineers hardly have experience with parametric modeling and optimization tasks. So they were quite overwhelmed with working with parametric software, parametric tool, and especially with the POD tool then So the qualitative results were like, we saw what are the potentials? What do they rate good? So they rate the ability to integrate structural design early in the design process has brought benefits to my architectural concept. So they think that integrating structural design really brings benefit in the architectural concept. The early integration of structural analysis into the design process has brought advantages for the structural design of the hall and a reduction of workload through quick variance studies. So the tool offered them the possibility to do quick variance studies with automated parallel structural analysis and optimization. And architectural students also say, I now better understand the impact of my design decision on the load-bearing structure. So it gave them some informed decision-making. But what are the improvements? So the improvements also in the tool and on the process is most of the students said they would have liked to have more training on parametric modeling and optimization in advance. Then they would have been more able to apply the POD tool. That means so the tool is not yet self-explanatory and you need pre-knowledge from parametric design. Then an additional information and data exchange strategy has to be set up within the team at the beginning of the project in order to be able to work efficiently with the tool. And they aim or they wish for a graphical interface to make the tool more applicable in practice. That means we need to have a graphical interface, and designers would wish to work not directly in the Grasshopper tool. So, but here I want to show you some project outcomes of two teams. Here you see the parametric script in Grasshopper 3D. Then you see how it was visualized in Rhino for the decision making. So the teams looked at these variants, at these outcomes, and then decided for the perfect outcome. Here in this graphic, you see you have the objective outcome, so they could compare objective outcomes. And here you see also the BIM modeling afterwards, what great projects they were able to design. What will be the next steps in our study? So we saw there are some script and process improvements, and especially on the interoperability and ease of use. So what we have already done now is we developed a graphical interface, so the designer don't have to work with Grasshopper directly anymore, so they can input their design demands, their design input in advance, and then the structural and layout script runs automatically. This is already done, and we implemented already more objectives. So it can calculate LCC, life cycle costs, life cycle analysis, and flexibility to increase the decision-making process on a higher level. And furthermore, a generative multi-objective algorithm is developed or has already been developed to automatically generate design solutions for the structure according to different layouts. And so we are now able to automatically generate building and layout variants. That was also done because the designers said, okay, we need improvement of handling, we need improvement of coordination and the variant study. And next, that to give them a more advanced design feeling, we will bidirectionally couple the script, which you see here, to a multi-user VR platform for informed decision-making with real-time feedback and visualization support in interdisciplinary teams. So the teams can walk through the building and change parameters, and in the background, the script runs and optimizes the building again when they want to see other versions. So the stakeholders can design and modify directly in VR in future, and the script serves as a background calculation. So if you want to have more information about the project or on the BIM Flexer or on the script, please feel free to contact me, and I'm happy to answer your questions now.